Hi ladies, it's Mr. O'Sullivan. Today, we already did this lesson. I'm very sorry that I didn't get the video lesson up before class. I was just running low on time, so I'm doing it now. So if you miss Zoom, please watch this lesson. That way you can understand everything you missed. That way you can understand your Delta Math assignment where you actually do some of these examples totally by yourself. So what we're doing today is we're going to be looking at lesson 3-6. This is our final lesson of the unit. So on Monday and Tuesday, what you're going to be doing is you're going to be doing some Desmos practice with transformations where you put everything we learned together. So the first two things we're going to be looking at today are compositions of transformations. So the learning target for today is I can transform a point or a figure by using a composition of transformations, and the transformations we're going to be looking at are reflections, rotations, and translations. There's one other transformation, but we're not going to learn about it just yet. We're going to learn about it in its own little unit in a few months. So one of the things I want you to think about today is, as we progress, is do you think order matters? So recall, below are some of the transformation rules that we're going to be exploring today. We're going to be looking at translations, reflections, and rotations. In translations, this is the notation we're going to be using, T and then like a little a and a little b. Remember, whenever you're doing a translation, you are just focusing on adding and subtracting. There is no multiplication and there is no division. Then we're going to be looking at some reflections. Whenever you see a reflection, I just want you to think of flips. When I reflect over the x-axis, I keep my x the same and I make my y opposite of what it actually is. When I reflect over the y-axis, I keep my y the same and I make my x opposite. There also are two other reflections I want you to know. I want you to know a reflection over the line y equals x. So when you do a reflection over y equals x, your order changes to yx. And when you do a reflection over y equals negative x, it becomes yx, but both of them are opposites. I can have negative y, negative x. So those are two other ones that you need to remember. And then our final area, we have a rotation of 90, a rotation of 180, a rotation of 270, and a rotation of 360. The rotation of 360 is the easiest one to remember because you're just going full circle. So when I'm going full circle, if I'm starting at xy, I'm going to end at xy. When I do a rotation of 90, I switch my x and y and I negate my first value. When I do a rotation of 180, I keep the order the same. I just make them both opposite. So I negate my x and y values. When I do a rotation of 270, I switch my x and y and then I negate the second value. And these you do have to memorize. So composition of transformations. By definition, they are a combination of two transformations performed in a specific order. So please pay attention to that. The first transformation produces an image, and the second transformation is performed using the first image. So this is very important because once you get to higher levels of math, you rely on what you're doing with other aspects of your function. So like, for instance, if you take calculus, you look at the chain rule. When you take algebra 2 trig, you learn about compositions of functions. I call them Fogg and Goff problems because there's a lot of F and G notation. So do you think order matters when performing a composition? Explain. This is just an opinion question. I like to be right, so I'm going to say yes, I think order matters, because when doesn't order matter? And order matters because, like, think of it this way. PEMDAS, factoring, and so forth. Like, you can name so many math procedures where order matters. So let's see if our hypothesis is correct. The first thing we're going to do, we have the point 25. And what we want to do is we want to perform a reflection over the y-axis. So we want to do a reflection over the y-axis first. When I do a reflection over the y-axis, my y value stays the same, my x value changes. So the opposite of a positive 2 is a negative 2. I'm not done yet because I also want to perform a translation of negative 3, 5. So I have to ask myself what negative 2 plus negative 3 is. Well, it's negative 5. And then I have to ask myself what 5 plus 5 is. 5 plus 5 is 10. So I get the ordered pair, negative 5, 10. Now we're going to do the exact same question, but this time we're going to do our translation first and then our reflection last, because we want to see if order actually matters. So again, I start with the 0.25. I'm going to do my translation of negative 3.5. I have to ask myself what 2 minus 3 is. Well, 2 minus 3 is negative 1. And then 5 plus 5 is 10. So my y value stays the same, which is cool. At least I think it is. And now I want to do a reflection over the y-axis. When I do a reflection over the y-axis, my y value stays the same, but my x value is what changes. So the opposite of a negative 1 is a positive 1, and I keep my y value the same. So when I do it in this order, I get 1 and 10. So if I look, negative 510 is completely different from 110, because my x values are different. So I can say that order does matter, because I'm not going to always get the same answer depending on which transformation I perform first. So notation of compositions of transformations. In this class, we're going to be using this raised circle, which simply means following. So whenever you see this symbol, I want you to think of the word following. So you're following something else. So writing these steps can take a while. We need to perform multiple transformations. So mathematicians create a shorthand way of writing this long process by using this symbol. So when we're using this symbol, I basically do the transformation that's closest to my point first. So one of the things that I tell my students to do is I tell them to draw an arrow going backwards. So look, I draw my arrow going backwards, so I know I have to do a reflection over the y-axis first, and then I'm going to do a translation on whatever that answer is. It's one of the things my geometry teacher told me to do. It's one of the things that stuck with me, and I just remember it, and I always do it because these problems do get a little confusing after a while, especially when you have so many steps you have to do. So let's do some of these examples together. So I'm immediately going to draw my arrow above it. That way I know I have to go backwards. The first transformation I perform is my reflection over the line y equals x. So here's how Mr. O'Sullivan starts them. He rewrites his point. He's going to perform the reflection over y equals x. And I know if I wanted to, what I can do is I can go back here. And if I forgot my rule, well, when I do a reflection over y equals x, everything stays the same except I flip my values. So I do a reflection over y equals x, my negative 2 comes first, and my 3 comes last. So I just do this. But I'm not done yet, because I now need to do my translation of negative 1, 4. So I'm going to do this because I'm running out of room. Oh, wait, I can make this smaller. 1 second. Cool, I can move it. Oh, wait, no, I don't want to move it there. Let's move it here so I have a little room. Good. So I now want to do a translation of negative 1, 4. And I have to ask myself what negative 2 minus 1 is. Well, negative 2 minus 1 is a negative 3. And then 3 plus 4 is 7. Negative 3, 7 is your final answer. Do not box the negative 2, 3. Only box the negative 3, 7. You only have one final answer for this question. Now, we're going to work backwards again. So I start with the point 3, negative 2. And the first thing I want to do is my rotation of 90. I'm giving you the heads up. I honestly always forget my rotation rules. So I'm going to go back up here. My rotation of 90. I flip my values, so it becomes negative yx. So I'm going to flip my values, so I have negative 2, 3. But I make my first value opposite of what it actually is. So I already have a negative here, but the negative of a negative is a positive. So this becomes positive 2. Now I want to do my translation of negative 2, 4. Well, I have to ask myself what 2 minus 2 is. Well, 2 minus 2 is 0, and 3 plus 4 is 7. So my final answer is 0, 7. Let's do one more. For this example, I want to do a reflection of the over the y-axis following a reflection over the x-axis on the point 3, negative 2. Remember, we draw our arrow going backwards. So I'm going to start with the point 3, negative 2. I want to do a reflection over the x-axis So when I do a reflection over the x-axis, my x value stays the same, but my y value changes. So if I'm starting with a 3, -2, my -2 changes to a +2. And these are all in the rules above here. So please, if you need to, take a screenshot of this or rewrite them. Okay, last transformation we do is a reflection over the y-axis. So I do a reflection over the y-axis. My y value stays the same, but my x value changes to an opposite. So my 3 becomes a -3. And that's my final answer. Let's do some graphing together. Before we even start graphing, so I know a few of us still struggle with the basics, so what I'm going to do is I'm going to put my plus here. So I'm going to do a plus, a minus, a minus. And this is what Miss Kimmick would always do, and it just always helps us. And then do my plus here. So I want to graph triangle ABC and triangle A. This is a typo. This should just be A prime, B prime, C prime. Graph triangle ABC and triangle A prime, B prime, C prime, the result of the transformation, rotation of 180 following a reflection over the x-axis. So right now we have 2 transformations going on. So you would think that we would have 3 figures total in our grid. But no, we actually only want 2 figures. We want our original and our final. So it's sort of like these examples. If I were to ask you to plot this on the grid, I would plot this point and my final answer. I would not be plotting my middle one. Because it helps you get your final answer. All right, so the first thing we're going to do is we're going to plot A -4, -5. So I go out 4, down 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. We're going to plot B -7, -8. And then we're going to plot C -4, -10. I'm going to connect those with some nice lines. And it's not perfect, but it'll do. So triangle ABC is in purple. And I want to graph triangle A prime, B prime, C prime, the result of the transformation, rotation of 180, following a reflection over the x-axis on triangle ABC. And it also says state the coordinates of triangle A prime, B prime, C prime. So what I'm going to do is I'm going to have this in a very nicely organized manner. What I do, and this is what my geometry teacher suggested, and I took geometry in 9th grade of high school, so I still remember some of these things. So I rewrite my points in order, so I'm going to do A -4, -5. I'll do it in the color I labeled it in. B is -7, -8. And C is -4, -10. The first transformation I want to perform is a reflection over the x-axis. So I'm going to do that reflection. And I write above each arrow. You don't have to. I do because I'm going to forget. I'm a very forgetful person. And I reflect over the x-axis. My x value stays the same, but this time my y value changes. So I'm going to keep my -4, but I'm going to change my -5 to a +5. I'm going to keep my -7, but change my -8 to a +8. I'm going to keep my -4, but change my -10 to a +10. And good. Now, you can plot these. Let's plot these just to practice. But we're not going to label them. So I plot -4, 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. We're not going to label them. -7, 8. And then I'm going to plot -4, 10. I'm going to connect those with a gray line or whatever this color is. And that's how I reflected this image over the x-axis. But the thing is, the reason why I'm not labeling it is because it's not my final image. when I only have one prime on each of my vertices, that means that this is my really only one transformation. So I really only see one image on my page. So don't label that triangle. So now I'm going to do my rotation of 180. And remember, an uppercase R means you're dealing with a rotation. And we do a rotation of 180. Our values stay in the same order, but we make them both opposite. So I have negative x, negative y. I'm just going to write that rule somewhere up here. So I keep my values in the same order, so I'm now going to write A prime, B prime, C prime. And the opposite of a negative 4 is a positive 4. The opposite of a positive 5 is a negative 5. The opposite of a negative 7 is a 7. The opposite of a positive 8 is a negative 8. The opposite of a negative 4 is a positive 4. And the opposite of a positive 10 is a negative 10. So we're going to label these points. So A prime is 4, negative 5. So I'm going to go out 4, down 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. Then I'm going to go out 7, down 8. That's B prime. So 1, 2, 3, 4, 7, down 8. And then C prime is 4, negative 10. And now I'm going to connect them. I'll connect them with red. So if you look, I now have my image. So I have a triangle ABC, which is my original. This is my middle. So basically like the image that helped me get my new one. So this is, how do I put this? Let's call this my helper. And this is my image. Your final answer. If you look, this sort of looks like it's a reflection over the y-axis. Let's verify it. So 1, 2, 3, 4. 1, 2, 3, 4. That works. 1, 2, 3, 4. 1, 2, 3, 4. Yeah, this is just a reflection over the y-axis. So if I wanted to take this one step further, I could have asked you, how can I write this composition using just one rule? Pretty cool stuff, at least I think so. And then this is what we were going to do in the breakout room. Here's the question. Well, we did this in the breakout room. You are a contestant on the Netflix show The Circle. You are searching for a hidden immunity idol in your apartment that will save you from being blocked on this week's episode. The writer for this week's show, though, is an evil mathematician. Your clues relate to a coordinate map. What are the coordinates for the location of this hidden immunity idol? So if you haven't seen The Circle, I definitely recommend it. Here are the 3 clues that you found. You start at the point 4, 3, and you want to move this image after a translation of x minus 8, y plus 4. So in the Zoom today, a few students were like, okay, so this is a lesson about composition, so I'm working backwards. But you're actually not working backwards for this one. We're giving you the clues in the set order. So you're working forward. So if I'm starting at the point 4, 3, and I want to do a translation of x minus 8, y plus 4, so that I can write as this. I want to find out what my new value is. Well, I just have to ask myself, what's 4 minus 8? Negative 4. What's 3 plus 4? 7. Boom. That's going to lead me to clue 2. Clue 2 says, now reflect this answer over the x-axis. So let's reflect it over the x-axis. So when I reflect over the x-axis, my x value stays the same, but my y value changes it up a little. So I keep my negative 4. And I have to ask myself, what's the opposite of a positive 7? It's a negative 7. That's going to lead me to clue number 3. So now in clue number 3, I want to do a rotation of 90 degrees. It says now rotate your answer 90 degrees counterclockwise to find the key. And as I said before, Mr. O'Sullivan does not always remember his rotation rules. So our rotation rule for 90 degrees is negative yx. So I'm going to write that up here. So I have a rotation of 90, which is negative yx. So I flip them. So I now have my negative 7, negative 4. But I am negating my first value. So my negative 7 becomes a positive 7. And that is how you will get your hidden immunity idol. So if I wanted to, I can write this using composition notation. So my original point was 4, 3. So I'm going to write down 4, 3. The first transformation I performed was a translation of negative 8, 4. Then I did a reflection over the x-axis. And then last but not least, I did a rotation of 90. So what this question is basically saying, if I wanted to put this into composition notation, is do a translation of negative 8, 4 on 4, 3, then do a reflect over the x-axis on that answer, and then do a rotation of 90 on that answer. And that's it. So that was like the idea of this question. We wanted to basically be able to then translate it to a composition at the very end. All right, ladies, so please pay attention. If you don't understand this video, watch the Delta Math help video. Also, come to an extra help session with either myself or Miss Daniel. And as always, if you have any questions, please email us. The only assignment is 3-6, this, classwork Delta Math. So that's how it's labeled on iLearn, and that's how it's labeled on Delta Math. So I believe it's only 5 questions. But make sure you show your work and then submit to iLearn. As always, have a great day, ladies.